Today I have a problem solving for x. We have the square root of x plus the square root of x plus 15 equals 5 divided by the square root of x. So this is looking pretty interesting right away from the start, because what I'm dealing with here is we have a lot of radicals all over the place. So first I do want to make the note that x cannot equal 0. That's really the only restriction right now, because if I have 0 here, this is the square root of 0, which is equal to 0, so then I'd have 5 divided by 0. We can't divide by 0. So we know x cannot equal 0, so then just keep that in mind as you work through it, that if you get 0 in the end, then there's going to be an issue. I'm not seeing any other potential issues with the domain in this problem. So let's just now start to go through it. My first step, I'm going to multiply each side by the square root of x, because I want to get rid of that square root of x. Now, are there other ways? Yeah. But I'm going to get rid of that square root of x by multiplying by the square root of x. So what's going to happen is I'm going to do square root of x times square root of x. Square root of x times the square root of x plus 15 equals square root of x over square root of x. So that's going to cancel out over there, leaving us with just 5. Now, the other ways of doing this, I'm not really sure off the top of my head, like how I could go about doing this. But if you have other methods, like, please feel free to share. But what I would do is I would just try to wipe out this fraction here. So I'm going to have square root of x times the square root of x. So we have square root of x times the square root of x. Look what happens here. This is going to be the square root of x squared, which is just x. Because the square root of x squared is x. Just like if I had square root of 2 times the square root of 2, that would be the square root of 4. Because 2 times 2 is 4. Square root of 4 is 2. So what happens is the radicals just go away when you're multiplying by the exact same thing underneath the radical. So that becomes x. Now that does not happen for this. It does not happen here. What happens here is I have square root of x times all in the square root of x plus 15. Now, since it is both under a radical, I would still do square root of x times x plus 15 times x. So I would still just do x times x and x times 15. I would still think of it, if you want, as like distributive property within the radical, because they're underneath the same radical of square roots. Like one's not a square root and one's not a cube root where we couldn't do anything with it, but they're both square roots. So we could just go ahead and multiply that through. So we would get the square root of x squared plus 15x. So I'm going to have the square root of x squared plus 15x equals, and then like I said over here, square root of x's cancel out, leaving us with just 5. I'm going to erase this work over here, and just to keep this kind of clean, I'm going to erase this over here. Okay. Wheels are in motion here, so we're looking pretty good. We're getting into shape. Now I have this radical still. I need to get rid of that. So now I'm going to get everything away from the radical. So I'll have the square root of x squared plus 15x equals 5 minus x. What do we do next? Well, if it's just like this, if I had the square root of x equals like 5, I would square both sides, because I would want to get rid of that radical. So squaring a radical would just get rid of it. Same thing here. I'm going to do the exact same concept where I'm going to square this. I'm going to square this. What's different, though, is this is going to be a little bit more complicated, because we have 5 minus x being squared. So on the left side, though, for right here, the radical just goes away. Just like how I showed you here, square root of x, and you square it, you just get back x. So I'm just going to get rid of that radical. So x squared plus 15x equals, and over here we have 5 minus x squared. So this is 5 minus x times 5 minus x. I like to multiply them out. I know there's ways of, like, you could just do the first term, and I understand that. I like to multiply them out. I just prefer that way. I'm not a formula memorizer, so I like to just work it out, and sometimes just even just do it mentally, but just for the sake of this video, I'll just show you the process. 5 times 5 is 25. 5 times negative x is negative 5x. Negative x times 5 is negative 5x. Negative x times negative x is positive x squared. And we have negative 5x, so 25 minus 10x. Why isn't that erasing? Minus 10x plus x squared. So we have 25 minus 10x plus x squared. My thought process originally was I was going to have to do some sort of factoring at some point, because I had this x squared here. But what happens is this kind of helps us out with the fact that, well, I have x squared because look what happens here. Subtract x squared, so 0 and 0. So I get 15x equals 25 minus 10x. Next, we'd want to just keep solving. So just solving a equation here. I'm going to add 10x over to both sides. So I'd have 15x plus 10x, which is 25x, equals 25. And then we divide by 25. X equals 1. 25 divided by 25 is 1. So we get x equals 1. Let's go back to the beginning. We talked about x cannot equal 0. We know that wouldn't be the worst thing in the world just to check your answer, just to, see if this actually works out, which I don't think we'll have an issue. We have square root of 1 plus the square root of 1 plus 15 equals 5 over the square root of 1. So square root of 1 is 1. 1 plus 15 is 16. Square root of 16 equals 5 over square root of 1. 1 plus 4 equals 5. 5 equals 5. Yes, it works out. And we knew 0 wouldn't work out, but 1 does work out. So good problem there. A lot of maneuvering, a lot of good problem solving.